Hello everyone, this is Mr. Appel, and today we're going to do what I think is probably the most challenging of all the quadratic word problems that we're going to see. So let's just kind of sift through this one. It's a little counterintuitive. So right now it looks like we have 60 students who are going to the prom. And right now tickets are selling for $50. However, the prom committee did some research and found that if they reduce the price by $5, 10 more students, the number of students that will go will increase by 10. So if they decrease the price by $5, the number of students will go up. So I'm going to do this sort of old, just like make a table to see. So like the number of students and the number of tickets. By the way, what I'm showing you right now is not what I actually want you to do when you solve this. I'm trying to help you see how the algebra we're about to do will make sense. So I'll show you in a minute how to do this without it. Okay, so right now there are 60 students going and they are selling 50 tickets. And so the revenue right now, is simply, how much revenue just means how much money are they taking in. It's not taking into account expenses. Revenue is just how much money are you taking in. And so 60 times 50 is 3,000. So they're taking in $3,000. So if they reduce the price by $5, so if, oops, I actually miswrote that, so this is super confusing. It's not the number of tickets at all. Sorry about that. It's the ticket price. Hopefully you caught that and were yelling at your screen. So the ticket price was $50. So if we reduce the price by 5, so if I subtract 5 from the price, I get $45. But they figured that 10 more kids will buy tickets. So the number of students will be 60 plus 10, which is 70. And so now our revenue will be 70 times 45, which is 3,150. And so we got more money, so that seems like a good idea. Well, let's keep going. What if they reduce the price another $5? So I'm going to write this in kind of a funny way so you'll be able to connect it. So I'm going to reduce it by $5, not once, but twice. So I'm going to take away $5 twice, I should say. So the price is now $40, and so I'm going to add 10 people twice. And so we're up to 80 students now. And if I do that, 80 times 40 is 3,200. So still making more revenue. So let's keep going. So now let's say I decrease the price 3 times. So I decreased it by $5 3 times. So now I'll have decreased it by 15, which will make the new price $35. But again, the committee says we'll have yet another 10 students buying tickets. So 3 groups of 10 students buying tickets. So now we're up to 90 students. And let's see what the revenue is then. If I do 90 times 35, the revenue is now 3,150. And so you'll notice that the revenue has started to decrease. It started to go down, right? You can imagine if I reduce the price too much, then you're not going to make any money at all, even if lots of people buy tickets. If I reduce the price down to 0, it doesn't matter how many people buy tickets, you're going to make no money. And so the goal is to maximize the revenue. Now that process that I just did, which was kind of just doing it out the long way, it wasn't so bad. And you can kind of see it seems like the maximum we can get is right there at 3,200. And it wasn't so bad. But we're interested in an algebraic solution to this problem because you can imagine there could be much more difficult situations and we want to be able to solve it. So I'm going to keep this here. What I'm going to do is just kind of keep this here but off to the side so we can connect back to it so the algebra will make sense. So what's tricky here is I'm going to let x represent the number of price reductions. The number of times I reduce the price, because that's actually what is changing. Now that affects the number of students, and it also affects the ticket price. So if I think about the number of students, how did I calculate that? Well, the number of students going was 60, plus it increased by 10 for each price reduction. So it was 10 times the number of price reductions. So if I reduce the price once, like I did here, the number of students went up by 10 times 1. If I reduce the price 3 times, the number of students went up by 3 times 10. So kind of a weird concept, but if you think about, again, connect it back to what we did in the table, hopefully that makes sense. At the same time, the price, the ticket price, started at $50, but decreased by $5 for each price reduction. Okay, so now if we think about revenue, let's write a function to tell us the revenue. Well, revenue is just the number of students multiplied by the price of the ticket. And so the number of students is represented by 60 plus 10x. The price of the tickets is represented by 50 minus 5x. And so we now have a quadratic function that should tell us the revenue for any number of price reductions. We want to maximize, so let's put this thing in standard form. So we're going to multiply that out. We're going to distribute everything, so that's minus 300x, and then that's going to be plus 500x, and then that's minus 50x squared. I'm going to put that in standard form. That's negative 50x squared plus 200x plus 3,000. And so that is our function for the revenue. Now I want to maximize the revenue, and so our old friend, negative b over 2a, negative 200 over 2 times negative 50, which is negative 200 over negative 100, which is 2. And so what did we just determine? We just determined that when x is 2, that will give us the maximum revenue, which is what we're trying to find. And so now let's answer the question. If the question is saying, what would have been the best price to sell the tickets for? So the best price would be 50, if we reduce the price by $5 twice, or 50 minus 5 times 2, which is 40. And so $40 is our answer. They could have asked how many students will come, which would have been, plugging x in for number of students and gotten 80. And they could have asked us how much revenue will we make, which would have been the 3,200. So that's all for now. Thanks.